Hey guys, welcome back to my channel. In this video, we will use the same dataset of the SMS classifier, and in today's video, we will use multinomial naive Bayes to train our model instead of Bernoulli ones. Okay, so all the processes will be the same as earlier, just the change will be like we will use multinomial instead of that Bernoulli ones. Okay, so let's go ahead and import our data. Okay, let me clear all the older outputs. Okay, let import our data and we will see the length of the docs, which is 5570. So if you remember, in our earlier video also the length was 5570, and the same process we are storing spam and ham in ham spam variable, and I am printing the spam rate, which is 13. Okay, and we are mapping ham as 0 and spam as 1. And the reason of all of these, like why we are mapping this to 1 and 0, I have explained in my previous video. So if you have not seen that video, please go ahead and see that video. Then I am dropping the class 1. Okay, why? Because we have created level column which stores the spam and ham as 0 and 1. So we don't require this class column anymore. So I will go ahead and delete the class column, and now our data should look like something SMS and level. Okay, so now in X I will put the SMS, and in Y will put the levels. And again we are splitting our data set in train and test. So the same thing is happening here also. Okay, and you can surely go ahead and test your data by printing the head. So it's a good practice, always print your data and see whether you are getting proper output or not. So here you can see in X train I am getting the actual messages, and in Y train we are correctly getting the column levels. So 0 means, if you see, we have mapped 0 as ham, so 0 messages are ham. So here all the messages are ham. Okay, now we are importing count vectorizer to create bag of words, and I am fitting extrain to bag of words. So bag of the compressed matrix has been created, and let's print the length of the keys, that is 7174. Okay, now as we are storing the matrices to these variables strain and xtest transform. So basically these are the transformed matrices. Okay, now let's go ahead and print the type of it this transformed. So you can see it's the sparse matrix. Okay, now building the model. So as earlier we have imported the models from sklearn, and in place of Bernoulli we are using multinomial, and we are initializing the multinomial, and we are fitting our model. And in my previous video I have told the difference between predict and predict probability. So if anyone of you remember that, you can surely write it down in the comment section. Okay, and in model evaluation we will first check the accuracy, which is in this case 98%, and the confusion matrix we will print. Okay, and now let's go ahead and print off some of the things, like true positive rate is 95% and true negative rate is 99%, 0.99. Okay, and let's print the precision also. Okay, print all of them together. F1 score is 95, which is quite good. Recall score is 0.95. Now let's go ahead and print the ROC curve also. Okay, so RAC accuracy is 99, which is quite good. And if you print our data in like threshold and TPR FVR, we will get something like this. Okay, now let's go ahead and print the ROC curve. So you can see ROC curve is also well aligned. We are getting the values hugging this area. So it's a very good graph for our ROC curve. So we want our data to be like this. We don't want to our data to be like this or like in this shape. We simply want our data to be hugging towards these lines. So this graph is quite well. That's all for today's video. In next video I will explain about advanced regression. So till then, bye bye.